today. And we have two students right now in the building, and we're gonna go over that, and then we're gonna let the student ask questions. So to begin with, the fundamental counting principle, the idea is that you always want to count all your possibilities. So for example, if you are trying to find the license plate for a tag of a car, and they are letting you have 2 letters and 3 numbers, or let you have 2 letters followed by 3 digits, and you want to know what's the total possibility or the total number of license plates you can have, we're going to use the fundamental counting principle. How many letters are in the alphabet? There are 26. So we have 26 letters. How many digits we have? There are 10. The digits are only 10. We have infinite numbers. So the digits are 1, 0, 1, 2. And those are all the digits, so all the numbers are composed of them. That's what these are the digits, all right? So we have 10 digits, 10 digits, 10 digits. So if you multiply that, how much is that?
Okay.
No problem, I didn't bring my calculator.
Oh, okay, let me do it.
So what was the L?
The L is the letter. So if you have a license plate,
Oh.
you have the option to do it, like AX038
Okay. You said times 10?
times 10 times 10 times 10.
That's 676,000.
676,000. So those are all the possible combinations. Those are the total number of license plates you can have if this state has that option. All right. Another example we can think about. Which one? So you go to an ice cream place, right? So you get a cone, right? And then you have the option to put 2 more toppings, right? For the cone, you have the option to get the waffle cone, right? Or you can get the bowl. And this guy has the option of being large, medium, small, right? So then you get 2 toppings, right? For example, you have 8 different flavors. And now the question is, you don't want to repeat the flavor, right? So you will not repeat. What you want to do is, on this side, if you have the waffle cone, how many options we have? We have to hold the ice cream, you have the waffle cone, that's 1 option. And then you have the bowl, which that comes with 3 options, right? So for the base, we have 4 options. Then you are going to add the 2 flavors. For the first flavor, you have 8 options, right? You don't want to repeat whatever flavor you put.
So you got 7.
You got 7. So you don't want to put 2 strawberries, you want to put strawberry and coconut or chocolate chip and milk. Yeah. I don't have too much time. So that's it, yeah. If we have to decrease something, we're just going to decrease. Any questions with that? Alfred? All right. Do you guys have any similar problems from the homework, from the review?
Yeah. I've had a question on the homework. It says something about dice. Let me find it. Yeah, it says 3 different. Yeah.
So the people that are watching the video can. 3 different. Okay. 3 different colored dice are rolled, and the numbers shown are recorded. How many different outcomes are possible? So we have 3 different dice. gonna do them. How many options does the first one have? If you roll it. 6, right? The second one will have 6 too. And the third one's gonna have 6. So 6 and 6 and 6. So that sounds right. I know them to but we can check it because I don't want to be completely wrong.
6, 216.
216.
Oh,
All right.
close.
Close enough. So if we have 3 dice, regardless of what the numbers on the faces of the dice, you always have 6 options per die.
Okay.
All right. No problem. Do you have a specific problem? No. Another thing. I saw a problem in there, the previous page.
Which one?
The person that actually has to travel. Can I read it?
Yeah.
All right. This one says, a boy owns 6 pairs of pants, 4 shirts, 7 ties, and 6 jackets, right? How many different outfits can he wear to school if he must wear one of each item? So we have how many pairs of pants we have?
6 pairs of pants,
6 pants,
4 shirts,
4 shorts,
shirts,
all right.
7 ties,
7
ties,
ties.
and then 6 jackets.
So you always have to multiply the options straight down. So 6 times 4 times 7 times 6. And that gives you a total of
1,000.
1,008. So how many outfits?
That's the combination.
They're all possible combinations. So he can wear, I don't know, he got the khaki pants. He can wear the blue shirt with a green tie and a black jacket. And then he can wear the green tie with the red shirt if you want to. And that will be another item. As long as you switch one item, that's count as a different item.
Okay.
A different outfit.
Can you explain just number 3?
Number 3?
Yeah, because it has 2 parts to it.
It's all right. So this has to do with allowance or not. All right, the question reads, how many 3-letter words can be made from 4 letters if repetitions are allowed, and then if repetition is not allowed? So 3-letter words. So we're going to have a word, 1, that's the first letter, second letter, the third letter. How many letters in the alphabet? 26. Since repetition is allowed, this will change the same letter and then the same amount of letters, right? And 26 and 26 and 26 equals, calculate people.
17,576.
17,500. That will be the total option, right? This is not allowed. For the first letter, we still got the 26. So we have to take one letter down. So we're going to end up with 25. And then take another letter out of the alphabet, and that gives you 26. So if the repetition is not allowed, we have to go down.
16,000.
So every time the resolution allows to always be bigger than not allowed, because numbers are same and same, we get that. So, there is one problem in the homework sometimes that has to do with a license plate, and sometimes you cannot put zero and the numbers are not allowed. I'm gonna go over that, and because it confuses sometimes people, and it's a good idea to work on it. So we have a license plate. And it will so we have 3 letters, then 3 digits, but 0 can be the first digit. So it seems a little tricky, but let's set out the problem first. We have first letter, second letter, and third letter. Then we got the digits. 1, 2, 3. The first digit cannot be 0, so we're going to mark it that 0 can be here. Let me know the digit. No. 0. All right. How many letters we have in the alphabet? Can we say that again? There's nothing about repetition, so we can keep the 26 letters all the way through. The first digit cannot be 0, and we know that we have 10 digits, right? So we cannot put 0 there, so we have 9 digits left. So the next one we have, I want to call it 10 and 10.
Where did you get
10 digits there.
even though there's no zero?
Only for the first one. So the first digit, 0 cannot be the first digit. So this is my first digit section. I don't, go ahead.
Can you clarify?
I start. I think exactly. So for my first digit, I only have 1, 2, 3, 4, 5, 6, 7, 8, 9. I only have those options. The 0 is a digit, but it's not allowed to go there. So for the options I have here, I don't know. For the rest, all of them can go in there.
Only if you take out. Oh, you took out.
Always remember, the numbers in here are the options that I have.
Okay.
So in here, I can put 1 to 9. In this one, I can put 1 to 9 and 0. I have the option. Good? All right. Do you have another question? Another specific problem? All right. Thank you so much, guys. This is the explanation for fundamental accounting principles here at the Learning Commons. Please don't hesitate to come up to the building. We are glad to help you. We're open from 7:30 a.m. to 7:30 p.m. Monday to Thursday, and Friday 7:30 a.m. to 5 p.m. Thank you.